Welcome back. In this video, we'll discuss section 5.6 on average value. Now, we know how to find the average of n numbers. You simply add them all up and divide by n. But how do we find the average value of a continuously varying function? For example, suppose we're interested in the temperature outside at time t. You'll investigate this function in the project for this section. In general, the average value of some function f on the interval from a to b is given by 1 over b minus a, so we're doing 1 over the length of the interval, times the definite integral from a to b of f of x. Let's look at an example. Find the average value of g of t equals 1 plus t over the interval 0 to 2. You can see I've drawn the graph of g of t. It's simply a line with y-intercept 1. We'll start by doing the calculation from above. The average value of g on the interval from 0 to 2 is equal to 1 over the length of the interval, so in this case 1 over 2, times the definite integral from 0 to 2 of the function, 1 plus t. To find the value of the definite integral, we need the net or signed area. Using the graph, we can determine that. And I've broken the region into two pieces. This R1 is this rectangle, and R2 is this triangle. Now, because the graph of G lies entirely above the t-axis, we're going to assign a positive value to the area. Area of region 1 is simply 1 times 2, the height of that rectangle times the base, plus the area of region 2 is simply 1/2 times 2 times 2, the area of that triangle, 1/2 base times height. So we end up with 4 for the area under the curve, and we multiply by 1/2, giving us 2 for the average value. Notice, if I go back to that equation for average value of g on the interval from 0 to 2, and I multiply both sides by the length of the interval, so in this case I multiply both sides by 2 minus 0, I get this equation. Average value of g times the length of the interval equals the value of the definite integral. And of course, the value of the definite integral is area under the curve. We saw that is 4. So we could think of this as the area of the rectangle whose height is the average value of g. So average value of g is 2. So I'm drawing this rectangle in red of height 2. And the base is the length of the interval, 2. The area of this rectangle should be the same as the area under the curve. And that makes sense. Notice when you form this rectangle that's shown in red, you've got this little triangular piece over here whose area is exactly the same as this triangular piece under the curve that's not part of the rectangle. So the area of this rectangle is the same as the area under the curve. That's all for now. See you next time.